Welcome, everybody. We're taking a look at the Cloud Native PG source code. This is Cloud Native PG. PG stands for Postgres. It's a way to manage Postgres clusters on your Kubernetes cluster. And I've had to use it the past couple of days, so I figured I'd look at the code. It's the first time I've really played with one of these Kubernetes database thingies. I don't know what the right term is. I think it's got an operator, but they've also got a bunch of CRDs, that is custom resource definitions. And it's a little bit weird because if you know Kubernetes, the pods aren't governed by like a stateful set or a daemon set or a deployment. They're governed, I think, by some Cloud Native PG specific resource. So it just seemed different enough, and I've never personally had to manage or worry about the statefulness of a database at scale, in the sense of running and scaling the database. I've consumed databases that were scaled and run by others, but I've never been on like the infrastructure team that does this sort of thing. So I thought it would be fun and or informative, or both, to take a look at it. So we see package. I'm guessing this is mostly Go. 98.4% Go. And governance. They've got the googly things. They've got the governance. And then, I mean, that's not googly. They've got the code owners. And they've got the Golang. And they're in Kubernetes. And they've the maintainers. I don't know how much sense code owners makes in a non-mono repo. In the Google mono repo, it's used to is like one of the several ways of kind of slicing up the mono repo, not so much into things that would be more like projects or repos elsewhere. Okay, so woke.yaml. Woke ignore. Woke must be a tool. What does it do? I don't know. Default rules master. This might be about naming conventions. Like don't like code that you commit to say don't use master, use primary and leader. File not found. Yeah. That seems to be, it's a text file analysis tool that finds places within your source code that contain non-inclusive language. It seems like you could use it for any sort of language rules. I don't know if inclusivity is like a technical, I think that's maybe about project scope rather than about technical scope. Okay, so docs, hack, internal, package, releases, internal. I like internal. I think hack is a Kubernetes thing. I never really have figured out what it's for. Maybe something about code generation. I don't know. I'm realizing I also don't have the chat up. Let me make sure that I eventually have the chat up. Okay. So API v1, I think the way that these projects go is that the API is really just the kind of API layer. I don't remember if it has the handlers, like any like business, what you might call business functionality. I don't know if it's there, but now that I'm thinking about it, package is where the stuff usually is in Go, right? Certs, yeah, here we go. Certs concurrency. I feel like they required me to use cert manager, which seems like not entirely unusual, but sometimes you install these Kubernetes things and they have like a specific way they want you to do certs or sidecars. And it's not necessarily like portable or composable with other stuff you might have. A config parser, I'm going to guess, is not so important. Management might be important. Multi-cache, I don't know. I'll open it, but I don't think it's going to be where I really want to get. We have PodSpec and Postgres. Logs, is that going to be interesting at all? I'm not sure. Reconciler, resources. service spec, and specs. System, utils, and versions. So system, I'll get concurrency. A is maybe cool. I don't know if I already opened it. Inserts is probably not cool, but I'm going to open it anyway. And I'm going to find resources and make it its own browser window. And so we'll look at this. And there's not much here. We have, I thought this was going to be like the CRDs. These are like retry test, persistent volume claim, metadata builder labels, and then status. Backup. So they support backup. I think they use barman. But this is 112 lines of code. And there's not much here. Flag backup has failed. It's just some function that you can call to flag the backup has failed. And you've got flag backup errors. This is a status resource. I guess it's just updating the status. Patch, I'm going to guess patch.go just updates patch statuses. Retry on conflict, etc. Okay. Very well. Let's look up the string custom resource. Here's some word list. Operator capabilities. This is just some documentation. Should we look at it? Traditionally, we do not. And we have operator capability levels. So I don't know if this is like one. I don't know if this is like a set of bootstrap phases. Operator SDK definition of capability. Okay, so this is just some standardized definition of what the operator is doing. Level 1 does automated application provisioning and configuration. And then you get level 2 is seamless upgrades. 3 is full life cycle, including backup, failure, and recovery. Level 4 is metrics and workload analysis, which seems weird because I guess you get no points for having metrics and alerts if you don't also do seamless upgrades, which seems a little bit weird, but that's the way it is. And autopilot, which includes horizontal and vertical scaling and auto config tuning. What we see in this documentation is that the capability levels map onto, I guess, operator features that are maybe some optional or something. I'm not sure. I'll read this later. But I'm guessing that some of these are optional. I don't know. Maybe they are all non-optional. Okay, I'm confident now that this is, I'm going to Naur certs. Executed go. This is maybe just concurrency inside the existing, like the code base of Cloud Native PG. I don't know if this is a concurrency that is visible like through the Kubernetes API. Executed can be used to wait for something to be executed. It has similar semantics to sync.const, but with a way to know whether it is already executed. I don't know. This is small. I think it's not so fundamental. System. What? System.go. Default core dump filter. I think system maybe means this is maybe code that's running on the Kubernetes node, as in the bare metal machine, to monitor all the like virtualized, containerized stuff. And so, for example, we see Darwin and Windows and Unix, and these are just, I guess, setting where the core dump stuff is, whatever a core dump filter is. Something about core dumps. Can be used to control which memory segments are written to the core dump file in the event that a core dump is performed. Okay, so you need to know, I guess, which part of the memory to write, and you probably don't want to write things like user data or passwords, and so maybe that's what it's used for. Maybe the good stuff is in specs. I had also done this custom resource definition search. Here's some customization stuff. They've got stuff commented out. This might be a comment describing like how you how you might use it. Here's some more customization. Config CRD. Maybe this is the right place to be. Config/CRD. I don't know if I consider the CRD to be configs. I think they're like configs with behavior, aren't they? I'm not sure, but we'll look at bases. This is looking promising. Let's look at clusters and databases and poolers and scheduled backups and whatever a subscription is. Okay. So this is a custom resource definition. I'm not sure if we've looked at one here before, and I don't think that I've ever written one. But it's just defining some resource. So it tells you what group it is. It's the PostgreSQL cnpg.io. And names. This is the cluster, right? Cluster resource? Yeah, okay. So this is the resource for clusters. And the name of the resource is cluster. So I think if you were to do like kubectl get cluster, probably with an underscore, it would show the, and it did like tab completion, it would show these resources. And then a cluster list is a list of clusters, etc. It's namespace scoped. Not everything is namespace scoped, but like many things are. For example, like cluster role bindings are not namespace scoped, but role bindings are. And then additional printer columns must be so they're going to like print the timestamp. They're maybe going to call it age. Status instances that they're going to print out, etc. And then we have some OpenAI v3. Sorry, OpenAPI. It's not the first time I misread that. OpenAPI v3 schema. So there's some OpenAPI schema. I don't know if OpenAPI is the same as what used to be Swagger. Yeah. Okay. So it's just some like JSON-y schema for APIs, and we get a API description here. API version, kind, properties. We've got some like affinity for the pods. So you want the Postgres is stateful, and affinity in this case is referring to like scheduling, I think, pods on the same nodes that they were previously scheduled on if you restart them, and so on and so forth. It may also refer to things like mapping to selectors or nodes that have specific properties, like a fast and big enough disk or whatever. Okay, so this is what the CRD looks like. Is there anything really that I want to get out of this? We have topology keys. This is a description. The pod should be co-located, affinity, or not co-located, anti-affinity, with the label selector in the specified namespaces. Okay, so it sounds like maybe this is just a knob you can turn to with label selectors, with labels, to do something. To select like co-locations, and it's not, you can't omit it. All right, so this is a cluster. But what does it have? It's not clear, like immediately at least, what I guess we have the affinity stuff. We also have number of instances. Okay. And maybe this is the thing that controls that controls the pods. What about like restart? Primary update method is restart. Method to allow the upgrade the primary server during a rolling update procedure. After all replicas have been successfully updated, it can be with a switchover or in place restart. I'm guessing switchover is maybe they spawn a new pod and then do the handoff, trying to do it as atomically as possible. And then in place, I guess they just restart the pod. And they have some enum. So I guess CRDs support enums. Or I don't know if this is a YAML feature. I think it's a CRD feature, but I don't know. Name of the priority class, and then what? Okay, so that's one CRD. Do we need to look at these other ones? Databases, maybe. The databases refer to their cluster. This is not names, right? Yeah, okay. So they know about the cluster, which makes sense. Whatever the PG name is, I don't know what in particular that is, and like whether it's applied. I don't know what applied means. Maybe whether the configuration is applied. Database is the schema for the database API. Okay. Maps to the encoding parameter of create database. This setting cannot be changed, so that you can state your encoding here. Database reclaim policy, which is the policy for end-of-life maintenance for the database, and it has delete and retain. And these are, I think, usually those are the same names that are used for like Kubernetes volumes or like persistent storage. I'm guessing that this is essentially under the hood configuring the persistent storage of the disks used by the Postgres cluster somehow. And we also have the name of the PostgreSQL cluster hosting the database. And I'm guessing this is name in the sense of like the name of the cluster resource, like the resource we just looked at. And then we have we can configure the extensions for managing the database. I don't know if we can like literally config the create data. Like, I don't know if you can put the like schema, the database schema here. Maps to the allow connections parameter and alter database. This is allowed connections. This is built in locale. Connection limiting. Collation version. Database reclaim policy we already saw. So what would that be called? That would be maybe called schema. Schema. The name of the schema in which to install the extension's objects. In case the extension allows its contents to be relocated. Okay. I'm in the wrong workspace here. That's unacceptable. Let's ask. Maybe, no? That's Flash. In Postgres, just ask the internet. PostgreSQL cluster contains one or more named databases. Okay, so the cluster has multiple databases. Yeah, and then what is a schema? The database contains one or more named schemas. So the cluster has databases have schemas, which in turn contain tables. And so the tables are properly part of the schema and not the database. Schemas also contain other kinds of named objects, including data types, functions, and operators. Okay. So what is really a cluster? I'll ask DeepSeek too. In Postgres, I don't want to deep think. If I have a single Postgres, let's say container, running databases for, let's say 12 apps, we'll just put them all in the same Postgres container. How many clusters would I have? How many schemas typically? Because I think there are different ways to do it, obviously. And how many tables? No, say roughly. Let's just do some estimate for tables. And I think DeepSeek has been slow. Oh no, it's going to respond quickly. You have one cluster. You have at least 12 schemas, one per app, but likely more. Okay, and roughly hundreds of tables. So this is really the question that I had about the cluster. A cluster is not a group of servers. A cluster is a thing that runs on a single node, I think is what it's telling me. And you would have different schemas for... A schema is a namespace within the... Okay, so schema is just a namespace. All right. Okay, so that answers that. And then I don't remember why exactly I had this question, but that's that. Let's go back to here. So this is for the database, which contains the schema. Okay, and did we see schema yet? We did not see schema. We saw cluster. Right? Wait, what? Did I just forget how this works? Yeah, the database does contain the schema. This is saying the... wait, how many databases did it say I would have? 1 to 12. That was really my question, I guess. Where do databases go? Yeah, okay, so databases would be 1 to 12, often 1 main DB or 1 DB per app for isolation. I'll say when do I use 1 per app database versus 1 database containing all the schemas. This is just standard Postgres stuff. I just don't happen to know it. But we need to know it to understand the code. The choice between 1 database per app and 1 database with multiple schemas is a fundamental architecture decision, et cetera, et cetera. Strong full process separation. Stop it. How do I scroll? Let me scroll. Let me click on this, please. Thank you. Okay, so in the same process. Okay, so if I run multiple schemas in the same database, they share a process? Is that right? All schemas within a single Postgres database are managed by the same server process. Okay, that I did not know. The other stuff I had known, I had just forgotten because it's such a crazy way to classify things. But that's how it is. Okay, so with that in mind, what else can we configure in the database? So I think the stuff like the table structure, that will be in the schema. The database is really what? Just governing the process, and presumably it has some things like permissions and ownership, including here. Okay, so schemas, the list of schemas to be managed by the database. So you can config the list of the schemas here. And so let's look at schema. This is poolers, scheduled backups and subscriptions. Great. Those are good. But I guess we don't have schemas as a separate resource. But you can name the schemas somehow. Specifies whether an object, for example, schema, should be present or absent in the database. Okay. The list of foreign servers to be managed in the database. I don't know what that means. Foreign data wrapper. So there's foreign data wrappers available which enable PostgreSQL server to different remote data stores, ranging from other SQL databases through to flat file. Okay, I don't know if this is for like a backup or replication. Basically, it's like streaming the the data to other things. So for example, how about geo wrappers? A wrapper for data sources with a GDAL OGR driver, including databases like Oracle, blah, blah, blah. Okay, but what is it for? What if I ask, what are they for? Hello, go. Oh, you can't hear me. Oh no, is my mic off? Hello, hello. Are you sure you can't hear me? That would be a tragedy. Let me double check on the here. So hello to the lurkers. I didn't know there were lurkers here, but I hear myself on the streamed YouTube video. So hopefully, I mean, I was silent for a second, so I might have just been thinking. But if you really can't hear my audio, I think I think it's correctly going to YouTube. And welcome, Bot Eater. It's good to see you. Okay, so foreign data wrappers is an extension that allows you to access and query. Okay, so you can query data from, it's for import. Oh, no. I don't know. As if it were a native PostgreSQL table. It's part of the SQL/MED standard, management of external data. It provides a flexible, no ETL solution for a variety of tasks where you need to integrate data from other systems without moving or duplicating the data. Okay, so you can link tables from, for example, MySQL, etc. Okay, so there must be a performance penalty. I'm not going to look into it. Okay. My real question is, can I define a database in YAML? Not that I would want to, but I kind of want to know if they do that. Here's the status of the managed schemas. What are the possibilities for status? So true if the object has been installed successfully in the database. Manage the object is something about a reconciliation message, etc. Okay. I'm just curious if you can do this. Declarative database management, which empowers users to define and control the lifecycle. Manages global objects in PostgreSQL, including databases, roles, and table spaces. However, it does not manage database content beyond extensions and schemas, for example, tables. To manage database content, use specialized tools or rely on the applications themselves. Okay, it sounds like you maybe don't create the tables. It manages global objects. Let's ask Flash now. In Cloud Native PG, can I declare? Can I declaratively create a table for my app using YAML and a CRD? We think the answer is no. How can I declaratively create tables? So obviously you can do it from like an ORM, like an object relational management manager. You can do it in things like Android, I think, using Raft, not Raft, whatever their database is. It's more or less declarative. You would define, I think, in Java or Kotlin code, but what you're describing is really a struct, essentially an object in Java or Kotlin, and that causes the correct database schema, I think, typically to be created, if I remember correctly. You can use a separate schema management tool, like Atlas or Schema Hero. Now, I can't create a table. There are schema things like Atlas or Schema Hero. Declarative schema migrations with the Atlas Kubernetes operator. Manage your database schema with Atlas. But what does that mean? A modern AI-powered CI/CD for database schema changes. AI-powered CI/CD for database changes. Why would I don't think I want AI power for my database changes. Use cases. Modernized schema migrations. And then there's pricing. It doesn't seem to be open source, so it doesn't exist in my world. Schema Hero. A modern approach to database schemas. We'll just still writing SQL migrations? And you can view it on GitHub. So this is something that's open source. I don't know anything at all about it. It might eat all of your data. It might be the greatest thing that ever existed. I just don't know. A Kubernetes operator for declarative database schema management. GitOps for database schemas. I'll bookmark it. Okay, so hopefully you can hear me now. Thank you. Thank you for, yeah, it sounds like you like restarted YouTube or refreshed the tab. I don't know what's going on. What kind of world are we living in? Yeah, I feel like AI powered database, like it's the sort of thing where you want manual controls over the migration. That doesn't mean you have to it doesn't mean that you have to write them in SQL as create statements. You can generate them, but you want them to be, you don't want AI to be, I think, too involved in modifying your infrastructure unless you really know what you're doing. And I think that, you know, just consumers of a web service are probably not in general in that category. Okay, so subscriptions, I don't really know what a subscription is. This might be using like Notify API, blah, blah, blah version. Create subscription command. Yeah, okay. Sounds like a Postgres subscription is a thing, a Postgres thing, and not a cloud native PG thing. Adds a new logical replication subscription. The user creates a subscription, becomes the owner of the subscription. It represents a replication connection to the publisher. Hence, in addition to adding definitions in the local catalog, this command normally creates a replication slot in the publisher. Okay. But what is it for? Is it different from like Notify? Is it like reliable Notify? Oh, yeah, okay, I saw this. What is the use case for Postgres subscription? Deleting DB. Yeah, I remember that post about Claude deleting somebody's database. They've Claude basically did that to me, although it was a test database. It had created like a Kubernetes resource wrong, and then it like changed some stuff, and I asked if there was any like leftover cruft from the first wrong version that it needed to delete, and Claude took that opportunity to generate all of my customize and pipe it into kubectl delete, which would have the effect of deleting not only the databases but like everything in the cluster. And if it wasn't a test cluster, if it was like a production cluster, which I obviously I wouldn't give Claude the right to use, that would have been disastrous. I had told Claude that it did not have permission to modify the cluster at all, and since then I've more actively denied its ability to try to run those commands. But basically, yes, Claude did that. Oh my. Claude is a little bit too aggressive with trying to do things. Like if you ask it a question, it'll often like just try to, if you ask it like, what's a good tea like to drink in the morning? It'll be like, oh, I think, you know, whatever. big low tea is good. I've ordered you a whole crate of it. And it will like, you know, you're asking for information and it's trying to like modify the world consistent with his answer. I don't know if that comes from like a built-in training to make Claude feel like it should be action oriented or what, but I find it unsettling. So Claude has reduced permissions compared to other AI LLMs on my machines. Okay, so PostgreSQL subscriptions are used for logical replication, allowing a subscriber database to receive changes from a publisher database. Okay, so I think this is really just for like replica backup stuff. But we're going to ask. I have been using the AI mode in Gemini. It's fast and kind of, it's not necessarily dumb, but it's not as good as the other stuff. But it's like pretty fast. Does anyone use it for publish, subscribe, data broker, stuffs with a Z? Okay, it says that people are using it maybe as a with like a message queue, tools like Debezium. Okay, there's a whole world of people who use Postgres for everything. I'm not in the world. I'm just using Postgres because I need a database, and I'm sure that its usages will grow as I need more things. But that's just managing subscriptions, which I think is mainly used here as a CRD for replication, and then scheduled backups. This is something about backups. I don't know really how they do it. I think they back up the folder. But for example, wait for archive. If false, the function will return immediately after the backup is completed without waiting for the wall to be archived. This behavior is only useful with backup software that independently monitors while archiving. Otherwise, wall required to make the backup consistent might be missing and make the backup useless. So they do have a good page that I've read about backups and what you should do, what you should not do. This is, I think, mainly just configuring the knobs for tweaking how the backups work. And then poolers, I'm not really sure what this is. Is this like a connection pool or like a load balancing? Specification for the desired behavior of the pooler. This is the cluster reference on which the pooler will work. This is just some, what is this stuff? Some enum, label, keep, label, drop, lowercase. I'm guessing this is replicating config from Postgres. Replace. Action to perform based on regex matching. Okay, so you have maybe some requests and you can do like a replace somehow, maybe in stream, maybe not streaming of the whatever you're doing, whatever that is. I don't know. I have a list of relabeling for the pod monitors. Okay. Cluster IP, etc. Okay, so this may be related to PG Bouncer. PAM authentication. With sharding, load balancing. Here's PG Cat. I think they use PG Bouncer. I mean, PG Bouncer tells me about its like updated features. I think this is its home, right? I mean, it's like that's like a commit log. What I want to know is what are you? So you've got session pooling, several layers of brutality when rotating connections. Most polite method: when a client connects, a server connection will be assigned to it for the whole duration it stays connected. When the client disconnects, it will be put back into the pool. Okay. And then transaction pooling, a server connection is assigned to a client only during a transaction. Statement pooling, most aggressive method. This is transaction pooling with a twist. Multi-statement transactions are disallowed. Okay. I don't know why you would use transaction pooling. I'm guessing this is maybe when you have more and more data. Okay, so this is I guess it's like keeping pools on the server side rather than like managing pools on the client side is what I think it's about. It's a well-known piece of software. I just don't really know what it's used for. Without connection pooling mechanisms, blah, 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 blah. All right, so what is the deal with PG Bouncer And can I use it to... What did I want to use it to? Sharding. Can I use it to shard? For sharding. Is there a GAI thing? I did GA. Maybe there's GAI. It can be used with sharding to help manage, but it sounds like it's not. It's not a tool for sharding on its own. Flexible pooling modes, etc., etc. Manages connections to each shard. Is there a pooler that supports automatic sharding? Okay, so PG cat, PG dog. PG cat is maybe a cat might have been meant in a different sense. PG dog, I'm going to guess, is definitely a pun, or vice versa. It can parse incoming SQL queries to automatically extract a sharding key, like user ID, to route the query to the exact shard. So you do have to use a sharding key. So your application has to be sharding aware. I think that's reasonable. Okay, so that's PG cat and PG dog and poolers. I think that this is PG bouncer related. The blah 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 to use PG bouncer or replace existing pods with new one. And then PG cat is nowhere to be found. Okay, so that's config. That I have a reasonable sense of the CRDs now. What do we care about? Maybe internal. We have command management controller, and this is the CNPI plugin. I think is a plugin for kube control, or kubectl as I call it. I don't know what other people call it, but I feel like kubectl is a good name for it. This is some scheme. What kind of scheme? Builder continues to build a schema with client go scheme with monitoring. I don't know what this is about. Abstractions everywhere. Well, abstractions can be good. You just want to have the right abstraction. So for Kubernetes, I think I talked about this before, but it evolved continuously from several things, including just like SSHing into boxes. And then like Borg at Google might have been the first one. And then they made a second one that was called like Omega or something. And then kind of Kubernetes is like the spawn of all of those things. And so through that process, kind of using it in anger over many years at scale, I think they got an idea of what the right sorts of abstractions were. So Kubernetes in general, I think does that really well. Third-party stuff like cloud native, it really depends on, to some extent, the maturity and the philosophy of the open source projects. Some open source projects are just kind of like aggressively like they're trying to like hack something together that works as quickly as possible and don't really care about like aligning so much with the ecosystem. And that can be valid to get started, but that is generally harder to use. Others, I think, really try to focus on digging down to what is the heart of the problem, building a small piece that they're pretty sure will work, like in the Kubernetes environment, and then the feature set grows more slowly, but tends to be nicer to use in the long run. Aggressively abstracted, yeah. So this is the controller. The controller should be the thing that does the controlling. It's going to like watch for state. So the CRDs are about state. The CRDs we saw are not the state that you configure, but like, for example, there was a cluster CRD, and there will be a corresponding cluster YAML file that you apply to your cluster. And the CRD is kind of defining the shape of what that file looks like. What are the fields? What are the possible values? And so there will be something that like watches for changes in your YAML configuration and applies and switches up the world, mutates the cluster to make the world consistent with the with what you've said you intend the cluster to be, and that logic I think should be in controller. PKI, I'm going to guess is keys, public keys. I don't want to dig too deep into the controller, but I do. Let's look at replicas. There's pooler update, pooler resources, pooler controller. I don't care so much about poolers since I didn't really even know what they were until a moment ago. Scale, I might look at. Cluster controller. This seems pretty fundamental. Backup controllers, maybe. They do have a test for backups. That's good to see. And rollout. What is it with rollout? This is maybe rolling out changes. We have plugins. And we have quorum on replicas. Now, I think a replica is a replica cluster. I don't know at what level replica lives. So if you have like a single cluster, basically what you might colloquially call a single database, basically one container running your Postgres stuff in this instance, there will the cloud native PG will configure a primary and two fallbacks, I think by default. And I don't know if those two fallbacks are considered replicas, or if a replica is a whole separate cluster that is maybe offsite or whatever. But we'll find out. We'll find out what the definition is. Reconcile target primary from pods. Sets the name of the target primary from the pod status if needed. This function will return the name of the new primary selected for promotion. Okay, I'm pretty sure now that the three pods, the one primary and the two backups, the two backups are considered replicas. Or maybe they're all considered replicas of each other. So we can check if the primary is primary. If primary is primary or cluster is replica. Cluster is replica. I don't know. Or primary is pod ready and blah, blah, blah. First step, check if the current primary is running in an unschedulable node and issue a switchover if that's the case. How could the primary be running in an unschedulable node? I guess maybe it can no longer be scheduled, but you haven't like drained it, I guess. And then second step, check if the first element of the sorted list is the primary. And to do that, we call cluster is replica. So what is cluster? I'm guessing it says cluster is a sorted list. I'm guessing that that means that the sorting is like from primary to secondaries. Let's look up the isReplica function. I don't know if I can click on it here. Cluster isReplica bool checks if this replica cluster is a replica cluster or not. So maybe, no, okay, I'm getting confused. I think each pod is a cluster, right? Before introducing the primary field, the enabled parameter was declared as a Boolean. Okay. Let's ask someone who's more knowledgeable here. So for here, when it asks if the cluster is a replica, is the cluster the same as a pod? Is a high-level logical resource. A pod is the smallest deployable unit. Okay. It checks if the entire logical cluster is configured to be a replica of another cluster. Okay. So if I have one cluster with 3 pods, are these considered the same cluster? I thought if I have one pod, that is considered a cluster on its own. So maybe the backups don't make it a different cluster. 3 pods are all components of a single larger cloud-native PG cluster. The cluster is the overall high-level database system. Okay. They're individual running instances, a blah, 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 blah. Yeah, okay. So a single pod is a cluster kind of only in a degenerate sense. And I think that makes that language make more sense. The primary pod handles all of the read-write operations, and the replica pods replicate data. Do they serve data? The replica pods serve data, e.g. read operations. Okay. Great. So all of that's good. Okay, so I was wrong. It sounds like this is for if the whole cluster is a replica of another cluster. And I don't know when that is necessary, but we do see external cluster here. Get barman endpoint CA for replica clusters. Checks if the replica cluster, which needs a barman endpoint CA. Much like a chain. You mean weirdly abstracted or with lots of clusters? Okay. All right. What is this though? User config map checks whether a given secret is used by a cluster. So how does it do that? It's got some string and something about metrics. If status config map resource version metrics config okay, return true. Otherwise return false. So cluster status. Okay, so it's looking in the cluster for the config, which I think is like just like the name of the config. Why is it a secret? I'm guessing maybe this got renamed from like uses secret to like more general resources. I don't know. I don't know if a config map is, if a secret is a config map under the hood somehow. Get server, CA, secret object. So there's a bunch of secrety stuff. Returns the type, blah, blah, pointing to the secret. Yeah, okay. So this is managing clustery stuff. I think we'll go on from here. Pooler update. We've got some reconcile service. Update deployment. We're going to get the PG bouncer deployment, which I think is basically the struct or the description of the resource. And if it's nil, we'll do a bunch of stuff. If we're down here, we'll say creating deployment. And we'll call all our create generated deployment, etc. So I think that the controller is maybe just or maybe primarily managing I don't know. I don't know if it's like kicking off any actual Postgres stuff or if it's just managing the relationships among resource definitions. Ensure instance is deleted. Log from context, ensure jobs are deleted. Okay. The way the whole thing is working on a high level. That's interesting. How so? How would you describe it as being similar to a GPU? I think that's an interesting idea. You do see, I guess, you do see a lot of ideas from kind of the hardware level reappear in the distributed computing level because they are both doing a form of distributed computing. And so, for example, something like scatter gather, I think appears both in the hardware level and in, something like Flume or what's the famous Google one that everyone knows that I'm forgetting about? MapReduce, as they call it. So there's some of that, at least in the CPU. I don't know as much about the GPU world. Cluster controller. Well, I guess what I want to know is like, are they calling Postgres? So let's think this through in one sense. So there is a Postgres container which is going to run the Postgres binary. They don't really ever need to run the Postgres binary from the controller. They may need to adjust the config. From what I've seen, the config, like PG HBA config or whatever, the configures like things like permissions and like where you're listening. That all goes into a config map. That goes into some YAML, so you can control it that way. And then the controller really would only need to make sure that config map is properly updated, and then the Postgres executable, the Postgres binary itself running in the container will consume the config. So they don't need to really run any Postgres commands, at least not in that sense. They need to do things like update routing and services, which some of that you configure manually yourself. Some of it, if you don't manually configure stuff, I think it's not hard to figure out how to decide what the default should be so that everything works. And I'm trying to think if there's anything that I really want to see that is describing their behavior. I'd like to see why pods don't restart when you change the number of instances. So bot eater is describing the parallel or analogy with between what we're looking at, which is the cloud native Postgres database stuff, with the GPU world. You have this whole thing running on the server, which is basically the thread engine. Yeah. Okay, which dispatches blocks of action to smaller clusters, SM. Okay. Which in turn manage their execution units. Yeah, I think that makes sense. And it makes sense yeah. I think that's right. I think that's one of the fun things about looking at the different scales. Google, I think they describe there's some, I think maybe some book. This is public though, but they think, at least used to think, I don't know if they do now, of all of their data centers and stuff as a single computer, kind of at the scale of a data center might be at the scale of a warehouse, is I think the word they used, like warehouse scale computing or something. I think that's changing because in the past they used to have now the computers are independent regional failure domains, at least publicly for cloud, because that's the way that Amazon did it. But I think back in the day, they were all part of the same computing system. And so one downside of that for cloud public customers is that a failure in like US East might cause a failure in somewhere in Europe. But if you want to think about just like large distributed systems, I think it makes sense to have like a world scale computer that you can think of kind of manages one unit. And in that sense, I think the analogy really goes through. And I suspect that the people who kind of worked on how to configure and manage the kind of large global scale computers and who built things like Borg, I think some of them probably were deliberately inspired or may have had a background in designing hardware, the hardware scale, the chip level scale is my guess. That's just a guess though. Okay. What I feel like I've seen most of the things that I want to see. I usually try to keep these around an hour because they just get too long and it overwhelms the senses. Where are we now? About an hour 5. Okay, rollout, go. Coordinate rollout. Last cluster coordinate rollout with time. And coordinate rollout with time is going to time since last rollout, now.sub, manager last update. Maybe this is subscription. If manager last update is 0, or the time since last rollout is bigger than or equal to t, where t is some duration that you pass in, then we'll set the last cluster to, I guess, the current cluster, set the last instance to the name, etc. And then we'll say rollout allowed. And where is rollout allowed used? Well, here's defined. Okay, but where is it consumed? Here, maybe. If not manager result rollout allowed, then we're going to record an event. Normal rollout delayed, rollout of pod, blah, 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 has been delayed for blah, blah, blah. And then we're going to pass in the PostgreSQL status pod name of the primary. And then we're going to pass in the time to wait string. So I guess this is being called on the primary because that's the pod that's being delayed. That's if there's no rollout allowed. When do we get down here? Error rollout delayed. Okay, so this is considered an error. This is just logging, right? Essentially recording an event. Okay. Is instance fenced? I don't know what it means to fence an instance. And what if rollout is allowed? I guess we call update primary pod. And update primary pod is here. We're going to pass in the context, the cluster, whatever a status list is, a pod list. Maybe this is just the thing that says like pod 1 is healthy, pod 2 is unhealthy, etc. And I think we're maybe going to make some changes here. Some logging, get primary update strategy. If the strategy is primary update strategy supervised, then it says waiting for the user to request a switchover to complete the rolling update. Okay, so supervised, I think really means human in the loop as opposed to supervised by the controller. And so they're going to ask for a signal. I assume that sends a message directly to the CEO, and the CEO has to thumbs up a Facebook message for this to happen. It's probably the standard way. And then we're going to say register phase. Phase, waiting for user. User must issue a supervised switchover. Otherwise, if the update method is primary update method restart or force recreate, and if in place is possible, I'm not sure where we sent in place possible. I guess it's here. We probably computed it somewhere that was maybe somehow related to the question of like whether the primary is on a schedulable node or not. So if the node is not accepting new pods, then for example, replacement is probably not possible. An in-place restart is possible, but if we're here, it is. An in-place restart is possible, and we're going to update restart annotation. So there's some annotation in the YAML, essentially, the Kubernetes config that says whether it can be restartable. And so I guess we update that, and something looks for the restart annotation to decide whether it can restart. And then we register a phase. Okay. So that explains that. And then what was it called? Restart annotation? Something must consume that restart annotation. Maybe cluster upgrade. Check cluster has different restart annotation. Pods.go. This looks promising. Cluster serial annotation name. Cluster restart annotation name. Watch label. PG data path. Create pod env config. Returns the hash of the pod env configuration. Great. This must be the thing that's controlling the pods, I believe. Create cluster pod spec computes the pod spec corresponding to a cluster. Yeah? Okay. So there's a pod spec. I don't think pod spec is a thing. I think it's a... I don't know if it's like a resource that exists in Kubernetes. Is it? A pod is a collection of containers that can run on a host. Maybe it is. A pod spec is a description of a pod. Yeah. Okay. No, a pod is a collection of containers. A pod spec is the description of the pod. It's just the YAML that says what a pod is. And then normally like a deployment. I spelled that wrong. So kind of the default behavior on Kubernetes for like pods is you'd have something like a deployment, or sometimes there's a thing called a stateful set. And there's replica sets. And so if you have some, I don't know, Kafka container, if you want to restart the container, you just delete the container, the pod. But the deployment is in charge of recreating the Kafka container with the right configuration and settings. So it's something that has a longer life cycle. And pods are essentially disposable because you can kill them and restart them. And as long as they come from the same deployment, then you have the desired behavior. Replace CEO with AS. I'm pretty sure that you're both. That may be true. That may be true. I don't know. Okay. Replica. And this is about quorum. So we're going to ignore this. I think we're just going to look at the pods.go. Okay. And you can probe some stuff. You've got readiness probes. This is just configuring all the pod stuff. This is not very abstracted now. We're just doing the equivalent of writing YAML with templates, I think. Metrics, et cetera, et cetera. If cluster annotations enable instance pprof annotation name is true, then they're going to do pprof, which is profiler, but is exposing TCP on port 6060. So maybe pprof has like a distributed serving thing. Maybe that's its main point. Pprof is a tool for visualization and analysis of profiling data. Web. Generate a graph of an SVG file, run pprof, blah, blah, blah. Pprof can read a profile from a file or directly from a server via HTTP. But what is it? Is pprof also the thing that collects the metrics, or is pprof just for visualizing them? I don't know. I don't know. Let's try cloud native PG pprof. Enable the operator. You need to edit the operator deployment. Add the flag pprof server equals true. It can expose a pprof HTTP server with the following endpoints: debug, pprof, etc. Okay. So my question is this a built-in part of pprof? Not that it matters. Maybe it's a Golang library. Package pprof serves via its HTTP server a runtime profiling data in the format expected by pprof. Okay. And it is something CS open source Google /go/go. Maybe it's what? Is this built into Go? I don't know. A standard library. Yeah, okay. It's part of the HTTP library, I guess. I did not know that. I did not know that. Okay, so if we enable HTTPS, which I hope you are, but I'm realizing I don't really know how Postgres handles HTTPS because they serve their own protocol, right? But you have this URI scheme, HTTPS, etc. Liveness probe, etc., etc. Okay. Cool. So they're really the reason that there's no like deployment, or I think I looked for replica sets. I can't quite remember, but I certainly looked for stateful sets. Is that they are managing it, I think, through here. Is there a replica set? And they're managing it in they're managing it through these annotations. And you can kind of like kill the pods, but they will recreate them. Okay, and cluster scale. I assume this is for scaling up and down. Scale down cluster handles the scaling down operations of a PostgreSQL cluster. The scale up is handled by the instance's creation code. Okay, so if you want to scale down the cluster, it's going to search for max sync replicas bigger than 0, and looks for the number of instances defined in the spec. So you define in the cluster spec how many instances you want. It checks that they are smaller than the max sync replicas plus 1. I don't know if this is user defined or not. In which case, this seems like this is like, okay, we can go. Then we're going to take a deep copy of the cluster. And the new cluster will have, what's the difference between cluster status? Okay, the new spec, the number of instances will be determined by the cluster status, as opposed to the cluster spec. I don't know when these are going to diverge in general. And then we're going to try to patch. I don't know why we need to patch. Oops. Something about the client. No? Seems like we did a deep copy. Oh, hang on. I guess cluster is the new one, and original cluster is the old one. And we're going to patch the new one from original. I don't know why we need to do that because we just copied it, but for some reason we do. And then we're going to record an event. Can't scale down lower than the max sync replicas going back to blah, blah, blah. Okay. And then is there an instance that can be deleted? We're going to find deletable instances. And there are no, if it fails, we'll say there are no instances to be sacrificed. Wait for the next sync loop. And I don't know how often the sync loop happens. And I also don't know what sets max sync replicas. Native PG supports the configuration of quorum-based synchronous streaming replication via two configuration options called min sync replicas and max sync replicas, which are the minimum and maximum number of expected synchronous standby replicas available at any time. For self-healing purposes, the operator always compares these two values with the number of available replicas to determine the quorum. That doesn't actually tell you whether they are in quorum. Synchronous replication is disabled by default. They are not defined. Okay. Do they actually have a quorum in the sense of like Raft or Paxos? Quorum. Evaluate quorum check. Fail over quorum types. Let's look at evaluate quorum check. Evaluate the quorum check algorithm to determine if a failover is possible without losing any transaction. True is returned when there is surely a replica containing all the transactions. False is otherwise. Okay, this is interesting. So we're going to get the object key from cluster. If something is not found, then we'll fail because there's no synchronous metadata available. And otherwise, we're going to return evaluate quorum check with statuses, which is hopefully the next function, and it is. It is used internally, primarily at the benefit of the unit test. So I guess it's easier to fake and mock and that sort of stuff. So coherence check of the synchronous replication information. If sync status standby number is less than or equal to 0, so there are no standbys. Unsupported synchronous nodes number. If the standby names, if the length of the standby names is 0, the list of the synchronous replicas is empty. That should hopefully not happen if the standby number is bigger than 0. Then we're going to detect promotable replicas. We're going to check if the pod is ready and put the candidates there. Evaluate the quorum, and here's the actual algorithm. Important, R plus W is bigger than N if and only if strong consistency, with N is the cardinality of the synchronous standby names set, and W is the sync number or 0, and R is the cardinality of the set of promotable replicas. And so this just looking at the cardinalities is strongly consistent. But wait a minute. How do they actually know if the data is all there? So this is looking at the replicas. I'm guessing that this must be implicitly or maybe even explicitly relying on the fact that somehow the replicas are aware of all being on the same page with respect to the transactions and the write-ahead logs and all that. Standard libraries can be so bloated. That's interesting. What was the application? The Go standard library, they built in lots of server stuff, I think on purpose, because they wanted it to be a very server distributed systems language. I think I'm going to close everything else, and I'm going to ask, maybe I should not have closed the reconciler, but I'm going to ask the AIs here somewhere. So this, let's grab this name. Okay, so in evaluate check with status, they do a strong consistency check that relies on cardinality of replicas, etc. It doesn't seem to explicitly check whether the replicas are all up to date with all data and the write-ahead log, etc. How do they know that the cardinality calculation is safe? Maybe the replica sync is how they know that the data yeah, maybe. Is that what it says? No synchronous metadata with status. So sync status, oh yeah, maybe here. Failover quorum status. Dumping the latest synchronous replication status. Okay. Yeah, I think you're right. So let's look at failover quorum. This is type. Maybe here. Maybe this is the place to be. Failover quorum struct contains the information about the current failover quorum status of a PG cluster. It is updated by the instance manager of the primary node and reset to 0 by the operator to trigger an update. Okay. And we've got metadata and objects, or rather type meta and object meta. I think this is just for JSON handling. The most recently observed status of the failover quorum. Okay, but what are the statuses? Creator quorum status. It's just a status object. Is that right? No, that's the name. And this is the type. And what does this failover quorum status have? The method, the standby name, standby number, and primary. I feel like that's not enough data. Oh, what? Okay. You found the missing piece. Have I? The instance sync.go file, I think maybe it's talking to itself again, reveals the whole picture. It's not just, yeah. This search was useless. Okay. As defined in here, I'll read that file. Okay. All right. It's talking smack about its own tools. Get it together, Gemini. You've hit on a crucial point. The safety of the evaluate quorum check with status function and its reliance on cardinality is based on the guarantees of PostgreSQL's synchronous replication, not a direct real-time data validation. Did I hypothesize that? That was my hypothesis. I said it out loud. I don't think I wrote it down. It's a classic example of a classic example. Everything is a classic example to the LLMs. I think mainly Gemini, but I think Claude might also do it sometimes. Relying on the protocol's correctness rather than re-verifying everything. Okay, so when you use synchronous replication, the transaction is not confirmed. Oh, okay. This is the piece that I was missing. So synchronous replication means it goes to all of the replicas before the transaction is confirmed and committed. So like I guess the client just blocks on it. It has been successfully replicated to a required number of synchronous standby servers. A required number. This is the fundamental promise that underpins the entire failover mechanism. And this formula is a classic quorum intersection formula. Yeah, it's fine. It shows that there's an overlap between the set of replicas that received the latest transaction, N, which N is the total number of replicas that were designated as synchronous standbys. To a required number of synchronous standby servers. Okay, so by required number, let's say I have like 16 replicas. Maybe 2 of them are standby servers that are like synchronous standby servers. And I think this is saying that N is 2 here. And W is the write quorum. And I think it's a subset of N. This is the number of synchronous replicas that must acknowledge the replication of a transaction before it is considered committed on the primary. And R is the read quorum. It's the number of currently available and healthy synchronous replicas that are candidates for promotion. Why is it they're called the read quorum? And you want the read quorum and the write quorum be bigger than N. It ensures that there's an overlap between the set of replicas that received the latest transaction, W, and the set of currently available replicas, R. Okay. Read, I guess, means that they're ready to serve, essentially. So they're healthy. And so you can promote them. Okay, that makes sense. You are correct that it doesn't check the walls directly. Instead, it uses is pod ready status in the absence of errors, etc. Okay. So that means that you can't use it with asynchronous replication, which is fine. You don't need to. That's the part I was missing. For a streaming replication, service will be either a primary or standby. Primaries can send data, etc., etc. Okay, great. That's cool. That all checks out. I think that there's not really anything else I want to see here. I just did a first pass looking at this code base, but I'm just a tourist. Is there anything super cool I should make sure to check out before I leave? You've hit the crucial point. You're absolutely right. They have these stock phrases. It's kind of funny. What did you have in mind about Yeeter? A fancy, I don't care about the CLI plugin. I mean, it's not that I don't care. It's just that it's a whole separate thing. And I don't care enough. The operator's brain. We looked at cluster controller. The in-pod agent. The code in blah, blah, blah runs. And so there's a sidecar container in his Postgres pod. This is the instance manager. It's responsible for tasks that need to be performed on the instance itself, like updating configuration files. Okay, that I think is pretty simple. And then the backups. Is the backup backing up and or snapshotting the file system volume, or is it calling the equivalent of PG dump? I think it's snapshotting the volume. I forgot. Okay. And it's handled at this point in a plugin, so I don't know if it's in the Git tree. It doesn't know off the top of its head. So the backup types gives us a clear answer. It's refreshing to see a well-defined API. Okay. Define the method field, which is one of the Barman object store to perform physical backup of the Postgres cluster. Barman does not use pgdump. Whoa, whoa. It creates a physical something, something, something. Where is it? Here we go. It creates a physical backup by using tools like pg-base backup and continuously archiving WAL files. This allows for point-in-time recovery in this volume snapshot method. Okay, I think that's about all I want to see. That was cool. That was fun. If you use Kubernetes and Postgres, maybe you're already using Cloud Native PG, and maybe you're not, but it seems reasonable. I don't see any reason not to use it. It's a little bit more complex than just spinning up a Postgres container with Docker Compose, but sometimes you need that. I guess they have no support for sharding. Does Cloud Native PG have any built-in support for sharding? And we can also ask this question of the internet. My guess is no. It's a hard enough problem. Yeah, I think it's no. Okay. Citus. What is Citus? Citus was one of the sharding thingamajiggies, right? Along with PG cat and PG dog. Plus horizontal scale. Okay. Well, they seem to have an open source repo. It's a PostgreSQL extension that transforms Postgres into a distributed database so you can achieve high performance at any scale. Okay. Cool. All right, that's it for me. Hope you enjoyed it. Thanks for hanging out, Bot Eater and the lurkers. And thanks for hanging out non-live to the viewers. And thanks for joining me on this exploration. And I'll see you guys again next week. I've got several videos and backlogs that I just need to post. And I will post them soonishly, hopefully next week by the time you're watching this, but we'll see how it goes. Thanks for watching and have a good weekend.